This problem deals with static friction. There will be no kinetic friction. We have a block on a tabletop. The mass of the block is 10 kilograms. It's currently at rest. The block has a certain weight W. There's a pushing force P directed to the right and downward at an angle of 40 degrees below the horizontal that is pushing on the block, not causing it to move yet. Opposing the tendency of the block to slide to the right because of the pushing force, there's a static friction force that progressively grows and grows and grows to match the increasing pushing force until the static frictional force can grow no more. The friction loses and the block begins to slide. We want to know what pushing force is necessary to put the block right on the verge of moving. The coefficient of static friction between the block and the tabletop is 0.26. Another force not yet named is a contact force between the block and the tabletop. The question we wish to ask, as I've already suggested, is what value of the pushing force will put the block right on the verge of sliding? When the block is right on the verge of sliding, it will have happened that the frictional force will have grown to its maximum value, can grow no more. And if it can grow no more, a slight increase in the current value of the pushing force will cause the block to slide. So we ask the question, what must be the pushing force when the static friction is as large as it's ever going to be? And the equation for the maximum value of the static frictional force is shown here in the case of a 0.26 coefficient of static friction. So let's go forward from this point to discover what P has to be. All right, once again, we need to find the value of P that forces the static friction to grow to its largest possible value, beyond which it's defeated and the block will begin to slide. Well, we're looking for the condition just before the block begins to slide. And prior to that, the block's not moving, so its x component of acceleration is 0. We require that the net horizontal component of force on the block therefore be 0, because the acceleration along the x direction is 0, so the net force component along that direction has to be 0. Hence, I make that statement. Well, f sub x is the sum of the 4 separate x components. X component of P, x component of F. Notice that I leave out the S subscript to remind us that it's static friction. We don't need any more reminders, so I'll leave the S subscript off. Plus W sub x plus C sub x. The sum of those 4 must be 0. Back to the P. Its x component is the magnitude of P times the cosine of 40 positive. The x component of the frictional force is the negative value of this, assumed to be the largest possible friction force. And it's negative because that frictional force points in a negative x direction. The x component of W is 0 because W is perpendicular to the x-axis, has 0 component, 0x component. Same statement is true about the contact force. It's perpendicular to the x-axis, has 0 component, therefore, along the x-axis. So we have a 0 and a 0. Now, I'll remind you, our goal is to determine the value of p. Here is an equation involving p. You can see that we can solve for p and be done with this problem as soon as we know the value of the contact force C. Let's go to work and get C. Well, to solve for the value of C that would enable us to get P, we do the following. We recognize that the block is not accelerating vertically along the y-axis, so the y component of the block's acceleration is 0, which means the y component of the total force is 0, and the total force is a sum of 4 forces: the pushing force, the frictional force, the weight force, and the contact force. And so demanding that the y component of the net force be 0 is the same as demanding that the sum of the y components is 0. P sub y, F sub y, W sub y, C sub y, add them all up, 0. Now, P sub y is the y component of this vector. Now, maybe you can see an error that is on the board. It would be good if you could. The y component of P is not positive P sine 40. Oh, no, no, no. It's negative P sine 40. I hope you agree. My mistake. And that mistake has propagated into the next line, so we're going to have to fix it too. Fun exercise. F sub y is 0 because the frictional force lies entirely along the x-axis. The y component of the weight force is m times g, negative sign, because the w vector points along the negative y-axis. Negative mg is negative 10 times 9.8, negative 98. The c vector has a y component that's equal to its full value, because the c vector lies entirely along the positive y-axis. When we solve this equation for c, what we get is the following. Change that to a plus sign. What's our next step? Our next step is to combine this equation with this equation. You will see that we made 2 equations. Those 2 equations involve the 2 unknowns, P and C. We're interested only in P. So what we do is take this expression for C and insert it right there, rearrange, and then solve for the unknown P. That comes next. I substituted the expression for C from this equation into that location in this other equation, and you can see the result involves a single unknown, the unknown that we're interested in, the value of P. I'll show you what I obtained for the value of P when I use the equation solver on my TI calculator. Final result, the pushing force required to cause the total x component of the force along the x-axis to be 0 is 53.57. The slightest bit of pushing force more than that number will cause the block to slide. So the answer to our question is effectively shown there. 53.57 newtons plus a little bit more, thousandths of a newton. The block slides. And by the way, once the block is sliding, a different type of frictional force will be acting. Still friction, but it will be the kinetic friction variety of friction. And as a general rule, kinetic friction for a particular situation is always less than the static friction. So you can expect the block will even more easily slide after it first starts to move. I hope this example problem, which is similar but not the same as one that's in the notes, will be helpful to you.